Transmission Control Protocol, TCP IP and computer networks. We are taking question and answer on this. Write the name of the well-known port used by TCP. So Transmission Control Protocol is a reliable protocol, connection oriented and process to process communication. Every TCP segment will be delivered. There is a proper flow control, error control, etc. So in TCP, or we are talking about those protocols which are using TCP. So those protocols we are discussing, they need this reliability. They want this packet to be delivered anyway. There has to be some retransmission if the packet is lost. There will be sequence numbering, there is acknowledgement, this all is happening. Okay, the first one is service. Service uses the port number 7. And this echo port just echoes whatever is sent to it. Both TCP and UDP it uses, but we are talking about TCP which uses. Discard is discard any datagram that is used. So 9 number port it is working. Then we have file transfer protocol, FTP. Now this there are two numbers here, 20, 21. That is whenever you upload, download, these file transport protocol normally works. When you send a file like FileZilla etc. you might have heard. So this TCP problem is if you use UDP, 1 byte mistake, the file will not open. So 21 is for all the control signals or control that is the establishment of when you want to file transfer, there has to be some establishment between two parties. And 20 is the actual file transfer. So there are two ports the FTP uses. Telnet which is the port is used by Telnet to remotely connect to a workstation or a server. So this is Telnet to remote access, remote login, etc. 23 port. 02, 1, 2, 3. These port numbers are well-known ports. Okay, you will not be getting these numbers. The operating system will not generate it for you. These are fixed for well-known ports. Simple Mail Transfer Protocol, SMTP 25, and this is used to send email over the internet. If you are using Gmail, Yahoo or Outlook, this Gmail is just a mail agent. So you have to have on the background something to send the mail to the mailbox. That is SMTP. To pick up this mail, that is POP3, Post Office Protocol. Then we have DNS. This www.google.com, this is the name, but there is an IP behind it. So DNS resolve this. So 53 is what DNS uses. Domain names system. Okay. There is a port for DNS request, network routing, zone transfers. Then we have Bootstrap protocol, BootTP 67 it uses. HTTP is very important because internet is everywhere. We are on www. So this is used for browsing web pages on a browser. 80 is the number. HTTP, Hypertext Transfer Protocol. And protocols are just the rules and regulation. For example, HTTPS, the port will be 443. And then I was talking about POP3, Post Office Protocol. This port is used to retrieve complete content from a server mailbox. See, it is not chatting. Mailing is not chatting. So first you have to send it to some mailbox. Then you have to pick it from the mailbox. So these are the well-known ports. Define the term endpoint in TCP. This is not the endpoints of the say server and client. That is the sockets. We are not talking about that. See, in any kind of connection for TCP, you need IP and port number. This is how the transport layer TCP works. And especially if you make socket, you need an IP and you need a port. So TCP here, the TCP is a transport layer protocol. So we are talking about endpoint, which is not the actual socket points, because this is end-to-end delivery. So let us see this endpoint which you see in this picture. TCP endpoint allows you to easily establish a communication over TCP/IP network connection between the client and the server processes. And these are residing on a different host, different computer. That is very important. Okay. So this TCP endpoint class follows a telephone-like model of networking. That is, previously we used to call on a telephone network dedicated. So client calls servers and servers answers the client. And once a network connection is established between these two, client and server, the two can talk to each other by reading from and writing to the connection. So this is the endpoint which you see here. So TCP endpoints, TCP uses port numbers similar to UDP, but the port space will be disjoint from UDP in TCP endpoints. And then each TCP endpoint will be identified by IP address and port number, which I just told you. So the entire connection will be IP port for server, IP port for client. It will be 4 tuple. Explain the error control mechanism in TCP. So TCP is a reliable protocol. It is end-to-end delivery protocol. It is a transport layer protocol. So end-to-end delivery and reliability can only be achieved when you have proper error control. So when you are sending packet, and if there is a problem, there has to be some way to retransmit. How to know we have to retransmit? There is an error, or there may be other things. So TCP protocol has methods for finding out corrupted segments, missing segments, out of order segments, and duplicated segments. So it has all the possibilities. That is how the error control is important in TCP, because of the reliability it provided. So TCP is in order also. That is, if you are sending packet 1 and 2, it will be delivered in the order 1 and 2 only. It will never be 2 and 1. So error control in TCP is mainly done through 3 simple schemes, which is the checksum, acknowledgement, and retransmission. These are the 3 error control in TCP. Checksum is simply you have TCP header, body, and the pseudo header. So if header is there, there will be a checksum portion. So the header, the pseudo header, and the data is the hash value is generated, and that is sent to the server. For example, you have 18, you are sending say 17. It is not 18. So the problem is there is some error. So what will be there? It will be a retransmission. In TCP, there is an acknowledgement also. The retransmission will be done when there is an error, the checksum has fault, or the acknowledgement is not received. This is the packet once you send from sender to receiver. Now the acknowledgement you don't get. Acknowledgement is all about I got the packet. Now this is the acknowledgement. I am acknowledging it. So the acknowledgement is lost. So packet 1 will be retransmitted. The packet retries sending after some timeout. There will be some timeout or some other mechanism which sends this packet 1 again, retransmission. Okay. So this is where we actually see that this is also an error control, because packet is not coming. The acknowledgement is not coming. So the packet 1 will be resent. Similarly for other packets also. There will be retransmitted until you get the acknowledgement. So checksum, acknowledgement, if you have both the problems or any of the problem, there will be a retransmit. So the error control is all about when the packets are lost or the packets are damaged. So there are certain ways, there are different layers checking different kind of error control. So we have parity checks, CRC, Hamming code, various are there. And there will be a retransmission scheme also. So the automatic repeat request error control is also done. Explain congestion. Congestion, when you feel cold, no, in your nose, you feel congested. Your throat also, the lungs also feel congested. That is, something is blocking something. So congestion is all about the network, say passage is blocked by or overwhelmed by the packets. So a state occurring in the network layer. This is about network layer we're talking about. When the message traffic is so heavy that it slows down the network. For example, this is the way, and the car are coming, the truck is coming. Ultimately, there will be a congestion. So network congestion in data networking, and also it is discussed in queuing theory. This is the reduced quality of service. As congestion is there, so quality will be less. Reduced quality of service that occurs when a network node or a link is carrying more data that it can handle. And typical effects including the queuing delay, packet loss, or the blocking of new connections. There is just assume there is a buffer and it can hold certain data or certain frame or packet, whatever terminology you use. If it is more than that, the packet will be dropped. So this is the concept of congestion. You have packet sent with respect to packet delivered. When the packet sent and packet delivery is equivalent, that is perfect. But sometimes this is not the actual fact. The desirable is what? The number of packet delivered should be somewhat near to packet sent. But when the packet sent and packet delivered has a huge gap, that is, delivered are less and packet sent are higher, that means there is a position of congestion, because you see packet sent is higher, congestion is more. What is the difference between stop and wait protocol and sliding window protocol? First of all, they both are for flow control. So you will see them you will talk about them in the different layers, data link layer also, and in the TCP, that is transport layer also. But we are talking about the core of these protocols. Okay. First thing, whenever you send, how much you are sending and how much you are waiting. In TCP, if I go to TCP, the header also, they exchange that, okay, this is my window size, this is my MSS, that is the maximum segment, this is what you can send. So they just broadcast it. But they declare it to the sender and receiver declare to each other. This is the window size. This is how the flow control is achieved. Okay. Now, when we are talking about different layers, these, because in the noiseless channel we use stop and wait. In the noisy channel we use sliding window protocol. In sliding window protocol we have 3 more versions. There are 3: stop and wait and all these ARQ and etc. But we'll talk about that. But let us see the difference between these two specifically. Stop and wait protocol, sender sends one frame and wait for acknowledgement from receiver side. So frame we are using because we know that it is data link kind of stuff. In sliding window protocol, sender sends more than one frame to the receiver side, and this is the window. This is not the actual window. This is a logical window, and retransmit the frames which is damaged or suspected to be damaged. Okay, the sender receiver sliding window is going on both the sender and receiver, and these are the number frames are higher. So what you see here, send but not acknowledged, already sent and acknowledged, not yet sent. So this sliding of window will take place when the frames are actually delivered or not delivered. So this is how we achieve the flow control and also the reliability, of course, especially in TCP. So in stop and wait protocols, sender send one frame and just wait endlessly for acknowledgement. If it comes, it's okay. Otherwise, it will wait. The efficiency of stop and wait is worse. Why? Because if the acknowledgement doesn't come back, what will happen? It will wait endlessly. The efficiency of sliding window protocol is better, because if you actually go to the detail of sliding window protocol, you'll see that the window will slide also, and there will be some retransmission also going on. So things are better here. The efficiency of sliding window protocol will be, I'll tell you the actual formula also just now. So the sender window size of stop and wait is 1. But what you see here, the window size of sliding window protocol is n. For example, this is 4. Sending the number is 4 here. Then receiver size, stop and wait protocol 1 and 1. So sender will also have 1. The window size, the receiver also will have the size as 1. Okay. When we come to the sliding window protocol, the sender window size of sliding window protocol is n, and the receiver will may be 1 or n. It can be 1 also, it can be n also. It depends on the receiver. In stop and wait protocol, sorting is not necessary. Here it may be required in sliding, it may not be. The efficiency of stop and wait protocol is 1 by 1 plus 2 into A. A is the ratio of the propagation delay and transmission delay. This comes while making the frame and sending and all this. So this A. And the efficiency of sliding window protocol is n by 1 plus 2 into A. A is the ratio of propagation delay versus transmission delay, and n is the number of window frames. This stop and wait protocol is half duplex. And as I said, for noiseless channel it is used, and mainly it is a data link protocol, data link layer protocol, and flow control. The sliding window protocol is full duplex. That is, both the parties are sending at the same time. What is a round trip time? RTT. This length of this is basically a matrix, so number. So length of time taken by a data packet to be sent to a destination. It includes what? It includes 2 times. The time it takes for an acknowledgement of the packet to be received at the original place. You are sending and you are getting the acknowledgement. So the total time is called as the round trip time. That is, if you are going somewhere and coming back, that is the round trip time. So for example, T sub P is the time. One hop and coming back, another hop, 2 TP is the round trip time. So RTT or round trip time is the total time taken to send the first packet to the destination plus the time taken to receive the response packet. This is the RTT. What is the significance of TCP acknowledgements? See, the reliability of TCP lies in acknowledgement. The acknowledgement number is 4 byte in the header of TCP. The sequence number is also 4 byte in TCP header. Checksum is 2 byte. So all checksum, the sequence number and acknowledgement number, they are very important. The window size is for flow control, checksum is for error detection, sequence number and acknowledgement number are for the reliability. So TCP acknowledgements are used to acknowledge packets that are successfully received by the host. When you talk to someone, what do you say? Hey, how are you? If the other person doesn't reply, you will be, in dilemma whether he heard or he doesn't want to reply. This is the same thing. You have to reply, oh, I am okay, how are you? So here the receiver has to reply. He has to give some acknowledgement. Then only things are fine in reliability aspect of TCP. So the flag, which is the, you see here in the header, there is a flag called ACK flag. And this flag is set if the acknowledgement number field contains a valid acknowledgement number. So TCP acknowledgement is all about that something has been acknowledged. So when computer communicate via TCP, the transmission control protocol, received packets are acknowledged by sending back a packet with the ACK bit set, ACK bit set. The TCP protocols allow these acknowledgements to be included with data that is sent in the opposite direction, and that is called the piggybacking. So this is piggybacking, but we are talking about the acknowledgements. Acknowledgement is the reliability basis. So I'll just tell you about this sequence number and acknowledgement number. See, because it is related. See, sequence number is whatever TCP segment you have sent, the byte, the data, 50 is the first number of the first byte because it is byte stream. First byte, say 100 bytes you are sending. Now the acknowledgement will come what? The sequence number is 50. The acknowledgement from the receiver will come as 51. Okay, I hope you got the idea. 50 is the first number of byte that is being sent. Acknowledgement will be 51. It is saying, the receiver is saying, okay, I got 50. Now I am waiting for 51. Same thing. When it gets 51, it will give acknowledgement as 52. I got 51. Now please send me 52. So the ACK will always be 1 plus the sequence number. What is retransmission? So retransmission is all about sending it again. Why you will send the packets or the segment or the frame, whichever name you take in whichever layer. Why do you transmit? The transmit is, if I say something to you, you didn't get it, you will say, oh, what did you say? I'll tell again. So the TCP transmission, it means resending the packet over the network that have been either lost or damaged. So retransmission is a mechanism used by protocol like Transmission Control Protocol TCP to provide the reliable communication. So what is the reliability? That if you lose something, I will cope up with that. Means I'll just send it. So the reliable communication means that the protocol guarantees that packet's delivery, even if the packet has been lost or damaged, it will be resent. The networks are unreliable and do not guarantee the delay of the retransmission of the lost or damaged packet. I'm talking about the actual networks. So some protocol like TCP have to provide the reliability. So the network which uses a combination of acknowledgement and retransmission of damaged or lost packets offer reliability. So acknowledgement plus retransmission is the key for reliability. So the TCP retransmission, it is just meaning that resending the packet over the network that have been either lost or damaged. So retransmission is just a mechanism used by protocol like TCP to provide reliability. This is a question: if TCP round trip time RTT is currently 30 millisecond and the following acknowledgement comes in after 26, 30 to 24 seconds, we'll take the first one. What is the new RTT estimate? There is a value alpha. This alpha is 0.9 here. So just this is the expression we are going to use. So this is the estimated RTT, which is estimated RTT into 1 minus alpha plus sample RTT new into alpha. So this estimated RTT will take as 30. The sample RTT we are going to take as 26, put the value 0.9 and 29.6. This is a new round trip time RTT. What are the features of TCP? Now you can add transmission control protocol with the transport layer work also, because the basic transport layer protocol is TCP and UDP. So TCP is all about end-to-end delivery, okay, process to process delivery. So let me just give you an idea about the upper layer. The application layer, for example, you are using Facebook or you are sending some data to someone. Now you are just sending the data. So the bytes are coming. So application layer is sending the data. Now there is a transport layer below it. So host A and host B has to provide end-to-end communication. So the application layer will send all the data to the below layer, which is the transport layer. Now I am talking about the TCP and UDPs. This is SCTP also, which is a finer type of TCP. I'll talk about that. But here TCP will take this data and convert it into TCP segments. and with these TCP segments are then sent to the network layer. So for example, HTTP will use TCP, and if your process is say some other DNS, it will use UDP. So now here the TCP is the sender and receiver. They start a conversation with a three handshaking in TCP. So they will first make a connection. That is why we are calling it as a connection oriented. So an application requests a connection to the destination using a handshake, and then uses the connection to transfer data. This is the first feature of TCP. Then stream data transfer. As I just suggested, TCP is byte oriented. It is the duty of TCP to pack this byte stream into packets. Actually, it is called as TCP segments, which are passed to the network, or you can call as IP layer, for transmission to the destination device. So TCP takes all the bits coming from bytes coming from the application layer and then convert into TCP segment, adds the header, and then transfer it to network layer. So it will make a TCP segment, and this is totally a byte stream. So this is the header of TCP. It can be 20 to 60 bytes, and it goes to network layer then. The important part of TCP is reliability. Reliability is achieved through acknowledgement and the retransmission. So if TCP segment has to get an acknowledgement. If you are not getting an acknowledgement, there will be retransmission. If some error is there, retransmission. It recovers data from the network layer if the data is damaged, duplicated, or corrupted. Point to point, end to end, process to process. TCP connection provides end-to-end delivery, that is from one point to another. That is the port from, see, in the header there are port numbers, source port number, destination port number. Source port number will be given by the operating system to you. And then on the destination port number, say for example you are using web or you are on internet accessing web page, the destination port number will be 80. So you are talking about point to point, end to end delivery, that is process to process communication is taking place here. Then we have the error and flow control. See, for flow control, there are various mechanisms. It uses the sliding window protocol and other protocols. The error for this, it uses the checksum. TCP uses checksum. In TCP, the checksum is mandatory. In UDP, it is not. So the sliding window protocol normally is used by TCP. So this is the sequence number, acknowledgement number. See, sequence number is 8000, acknowledgement is 8001. So acknowledgement is acknowledging that this sequence number, that is the first number of the byte, has been sent. Okay, thank you. But if this acknowledgement is not sent, there is a problem, retransmission. Error is checked by checksum. Checksum is header plus the data, that is the payload, plus a pseudo header. We combine them, create a hash number, and send it to the receiver. The receiver will match these numbers. If the numbers are not good, it will say, please retransmit. So flow control is all about sliding window protocol type of protocols like the window size. So there is a broadcast, there is a arrangement that this is my window size, this is my window size, this is my MSS, this is the segment. Don't send more than this one. Full duplex. TCP provides full duplex, means the sender is also sending it at the same time the receiver is sending. What is SCTP protocol? This we are going to take in the next discussion. Thank you so much. Take care.